In this video, I'm going to explain the solutions of examples on page 76, 77 and 78. There are 6 examples. The first example, calculate the resistance of an electric bulb which uses 15 ampere when connected to a 220 volt source. We are given current I is 15 ampere and the voltage is 220 volt. The potential difference is 220 volt and we are going to calculate the resistance. R is equals to V by I. It is according to Ohm's law. So V is 220 and I is 15. And what do we get? 15, 5 3s are 15 and 5 4s are 5 4s are. Then we have to divide 44 by 3. 44 by 3 is 3 ones are 3, 4 minus 3 1. Then we can take down 4. 3 12s are 3 4s are 12. 2. It cannot divide, so there will be a decimal point. 23 6s are 18, again 2. So it will be 666. The resistance of the conductor is 14.67 ohm. The next question is, a simple electric circuit has 40 volt battery and a resistor of 100 ohm. What will be the current in the circuit? We are going to calculate the current. The given are the potential difference of the battery is 20 volt and the resistance of the resistor is 100 ohm. To calculate I, applying Ohm's law, I equals to V by R. Here V is 20 and R is 100. 2 5s are, or you can write 0.2 ampere. The unit of current is ampere. And question number 3. Calculate the resistance of 50 meter length of wire of cross-sectional area 0.01 millimeter square and resistivity 5.0 into 10 power minus 6 ohm centimeter. In this problem, we can see that the resistance or the length of the conductor is 50 meter. It is in meter and the cross-sectional area is given in millimeter, and the resistivity here we can see that centimeter. Ohm centimeter, it is centimeter. Let us choose the SI unit. SI unit of length is meter. We have to convert everything in meter. For example, a to the power 5 by a to the power 3 is a to the power 5 minus 3. For the same base, when we take 3 up, it becomes minus 3. So it is 5 minus 3 and it is a square. Okay. If it is minus 3, what will it be? 5 by a power 5 by a power minus 3. If we take it up, it becomes a to the power 5. It becomes plus 3. 5 plus 3 is 8. It will be a to the power 8. Okay, you have to remember this. Question number 2 or number 3, the length is given, it is 50 meter, no need to convert it. What else? Cross-sectional area, it is 0.01 millimeter square. Let us convert this into meter. It will be 0.01, and there are 1000 millimeter in 1 meter, so 1 by 1000 meter. It is square. 10 power 0.1 is 1 by 100, so 1 by 10, how many zeros will be there? 3 square, so it will be 6 zeros. Meter square. It is 1 by how many zeros? 10 to the power 1, 2, 3, 4, 5, 6, 7, 8. 10 power 8 meters square. Or we can write, it is, if we take it up, it becomes 8 becomes minus 8, so it will be 10 power minus 8 meters square. And that is the area. Okay, the area is 10 to the power minus 8 meter square. Then about the resistivity, it is 5 into 10 to the power minus 6 ohm centimeter, and it is resistivity. Here we need to convert it again. 5 into 10 power minus 6 ohm, 1 centimeter is 1 by 100 meter. It is 10 to the power 2, 10 square. It is 10 square. Okay, so 5 into 10 power minus 6. If we take this up, it becomes minus 2. Okay, plus 2 becomes minus 2 ohm meter. Then we get 5 into 10 power minus 8 ohm meter. It is 5 into 10 power minus 8 ohm meter. Now we can calculate the value of R. The formula of resistance in terms of resistivity is rho L by A. Rho is this one, 5 into 10 power minus 8. Then L is 50. And A is 10 power minus 8. 10 power minus 8 and 10 power minus 8 cancel. Then we can write 5 into 50 is 250 ohm. The unit of resistance is ohm. The next question is a wire of resistance 12.2 centimeter, 12.2 ohm and length 80 centimeter has a cross section of 0.02 centimeter square. Calculate the resistivity of the wire. Let us write the given first. The resistance is number 4. Resistance is 12.2 ohm and the length L is 80 centimeter. What else? The area of cross section is 0.02 centimeter square. Here both are in cm, no need to convert. To calculate the resistivity, it is RA by L. Resistivity is RA by L. Let us put the value. R is 12 12.2. 12.2 is 122 by 10. Okay. L is A. Let's write A first. A is 0.02, so it is 2 by 100. 2 zeros. And L, it will be in the denominator. It is 80 centimeter. 2 40s are. Then this is 2 6s are, 2 1s are, 2 20s are. Then what do we get? It is 61 by 2 followed by 1 2 3 4. 4 zeros. We can write it as 61 by 2 into 10 power how much? 1 2 3 4. 10 power 4. Okay. Let me divide 61 by 2. 61 by 2. 2 3s are 6. 1. 2 zeros are 0. Then 1 minus 0 is 1. We can put point here. 2. Then put 0. 2 5s are 10. It is 30.5. 61 by 2 is 30.5 into 10 power. If we take it up, it becomes minus 4. The unit is ohm centimeter. Then, if we write it in standard form, decimal point must come after the first digit. 3.05 into 10 power minus 5. Sorry, it will be 3. If this decrease, this will increase. It will be 3 ohm centimeter. Then the next question is question number 5. In this question, a piece of wire of length L is drawn by pulling it till its length becomes true L. Compare the new resistance with the original value. Here we are given a wire of length L. Let the original length be L1. Okay. It is L. L1 is L. Then the cross-sectional area is A1. Or let it be A. A1 is A. It is drawn into double its length. So the new length will be L true. It will be true L as given by the question, and there will be change in the area, the cross-sectional area. Let it be A true. We do not know the value of A true. It is clear that when we pull it to L, the volume does not change. The volume of the wire does not change. Using that, the original volume is equal to the final volume. V2 is equal to V1. The volume is A into L. Cross-sectional area into the length. So V2 will be A true, L true, and V1 will be A1, L1. A1, L1. Here we are going to calculate A2. A2, L2 is true L. A1 is A. Then L1 is L. What is A2? A2 is AL by 2L. We get A by 2. The new area is A by 2. Okay, so we can calculate the resistance. L1 is L, L2 is 2L, area. A1 is A, A2 is A by 2. Then let's calculate the resistance. Let R1 be the original resistance. It will be rho L1 by A1. And A2 is, let it be equation 1. And R2, the new resistance. This is the original resistance. This is the new resistance. It will be rho L2 by A2. Why do I put the same resistivity? Because the resistivity does not depend on the length and the area. It is a constant. It does not change with change in area and length. Before that, R1 is rho, L1 is L, A1 is A, R2 is rho, L2 is 2L, A2 is A by 2, and it is rho 2L by A into 2. Take 2 up. So we have R2 is rho, let's take it out. 2 into 2 is 4. 4 L by 4 rho L by A. 4 rho L by A. In equation 1, we have this. Let this be equation 2. Compare the equation 1 and 2. What do we have? To compare the two equations, let us divide one equation by the other. Let us do like this, dividing equation 1 by 2, or we can do it 2 by 1. Okay. Dividing equation 2 by 1. What do you get? R2 by R1. 2 by 1. So it will be R2 by R1. It is R2 is 4 rho L by A. R1 is rho L by A. Rho and rho cancel, L and L, A by A and A. So we have R2 by R1 is 4. We can conclude that the new resistance R2 is what? R2 is cross multiplying 4 into R1. 4 R1. This is the new, the original resistance. The new resistance is 4 times the original resistance. Write in words. The new resistance is 4 times the value of the original resistance. Okay. Then what else? Question number 6. In question number 6, the potential difference between the terminals of an electric heater is 60 volt. When it draws a current of 4 ampere from the source, what current will the heater draw if the potential difference is increased to 120 volt? Here, for the first case, let this be the heater, electric heater of resistance R. It is connected across 60 volt battery. 60 volt battery. it gives current of 4 ampere. It draws a current of 4 ampere. So if we connect the same resistance, the same heater of resistance R, the resistance is not changed when we connect to another battery. Here the source is 120 volt. We are going to calculate the value of I in this case. Let this one be case 1 and this one be case 2. Question number 6. Case 1. From case 1, we can calculate the value of the resistance using Ohm's law. In Ohm's law, R equals to V by I. Then what we get implies R equals to V is what? V is 60, I is 4. This is V, this is I. Then we get 60 by 4 is 15 ohm. Then case 2. In case 2, we are going to calculate I. From Ohm's law again, I equals to V by R. The voltage becomes 120, but the resistance does not change. It is 15. Cancelling, we have 3 5s are 3, 3 4s are 3 zeros are 5 8s are, and it is 8 ampere. So this current is 8 ampere. Thank you.